Hello everyone. So this is just a bonus video, and in this video we'll find out the location of the center of mass of laminar surfaces who are bounded by curves. Now I have already drawn a regular curve, a continuous curve, and the area surrounded by this curve and the x-axis is denoted in the shaded region, and the limit of x ranges from a to b. Okay. And for any continuous body or for any continuous laminar bodies, the formula for finding the location or the coordinates of the center of mass is this for x coordinate and for the y coordinate. Now for general bodies, like for a surface hemisphere or for a semicircular region, it is easy to find out as those are regular bodies and we know the area very easily. But for this kind of bodies, we need to do a little bit of more mathematics. So first we will find out the x coordinate of the center of mass, and according to our general formula, we will take a strip at a distance x of thickness dx. Okay, and we have already taken sigma as the mass per unit area. So if we apply this here, we will need to write x into where dm must be sigma into area of this strip, which will be fx into dx. Okay, so this will be sigma into fx dx divided by integration dm will be sigma into fx into dx. Okay, now as you can see, the body is uniform, so sigma will just get cancelled out and we'll get the final relation as integration f into x into dx, whereas integration fx dx is nothing but the area under the curve. So we'll write it like this. So this is our formula for x coordinate. Okay, now the formula for y coordinate. The formula for y coordinate is a bit tricky, but don't worry. So for y bar, we need to write integration y. Now here y will be the location of the center of mass of this strip, which is at its middle. So if this is fx, then this length must be fx by 2, right? So we will just put y equals to fx by 2. So it will be fx by 2 into, just look at this formula, and dm will be sigma into fx dx divided by integration dm will be again sigma into fx dx. Similarly, the sigma gets cancelled out, and in the denominator you have the surface area, and in the numerator you have a half fx square into dx. Okay, just remember there must be a half when you are determining the y coordinate of the center of mass. So remember this two formulas, it will help you while solving many advanced level problems. This formula is also very important in engineering problems also. Okay, just write down these two formulas and we will be using in our further questions. Okay, so let us utilize this formula and solve an easy question first. So our question number 1 will be, we'll consider a parabola, a portion of a parabola. Let the equation of the parabola be y square equals to x. Okay, and let this location be 0 0 and let this location be 1 comma 1, and we need to find out the center of mass of this shaded region. Okay, the region is uniform, so the mass is uniformly distributed, and we will use those two old formulas, that is x bar equals to 1 by a integration x in times fx into dx, and y bar will be, remember, the half and fx square dx. Okay, so our first task will be to find out the area, this shaded area. So this is not a big deal, we'll just, so here y will be equal to fx will be equal to root x, so integration root x dx, and the limit will go from 0 to 1. So this is a very simple integration, we'll get 3 by 2 divided by 3 by 2, and the limit goes from 0 to 1, so the final answer is 2 by 3 units. Okay, now let us come to the x coordinate of the center of mass. So we'll just put our values, x into, we have fx as root x into dx, limit goes from 0 to 1, 3 by 2 integration 0 to 1 x to the power 3 by 2 dx, that will give you 3 by 2 into x to the power 5 by 2 divided by 5 by 2, and limit goes from 0 to 1, that will give you into 2 by 5, 3 by 5. So we have already got the x coordinate of the center of mass. Now for the y coordinate, again 1 by 2 times of the area into integration. Now remember here it is fx square, so fx square, that means y square, that will be equal to x, so it is x into dx, limit again goes from 0 to 1, and the final result becomes this. So we have already got the y coordinate and the x coordinate, so location or coordinate of center of mass for this surface will be 3 by 5 comma 3 by 8. Okay, so in my next video I'll solve another question related to this topic. So I'll end this video here. I hope you found this video informational and helpful. Thank you.